Hello everyone, this lecture I'm going to record for term 7 of process engineering students at Memorial University. We are going to look at how we do the dynamic process simulation in HYSYS. Here I have an example to elaborate this in my workbook 3. So we have the system here where we have the feed coming into the tank, and we have water coming out and we have the air coming out. There are two valves that we are using here. One is a reverse action valve, and the second type is the direct action valve. Before going into the solution of this simulation, I would just like to take you and define and explain what does these two valves means. So in case of the reverse acting controller, a reverse acting controller is a one whose output tends to decrease as the measurement signal increases. By that I meant to say, for example, I have this tank which has the water in it, and I have a reverse action valve which is installed at the inlet. If the water level increases in the tank, then what action it will take? It will close the valve here, because your process variable is going above the set point. Therefore the output will be reduced. So such kind of the actions or such kind of the controllers, they are called as the reverse action valves. Now the second type is the direct action valves. In our direct action valves, it means that the controller output rises if the measurement increases. So by that I meant to say, we'll take the same example of the water level in the tank. If the water level in the tank is increasing, then what will happen? This valve will open and it will let the liquid drain out of the tank so that it can achieve a set point here. So the process variable increases above the set point, so the output will also increase. So these are the two basic definitions of reverse action valve and direct action valve. So let's go into the problem and understand it, and then we will do it in HYSYS. So our feed containing the water, we have the composition of the water and air of 1000 kilogram per hour at 20 degrees Celsius and 5 bar pressure enters the tank. The tank has a volume of 5 meter cube. Consider a pressure drop of 1 bar for each valve. Now this one you need to understand what does it mean. By taking a pressure drop of 1 bar for each valve, that means to say, if we have the water flow, let's say, coming here, after every valves there will be a 1 bar pressure drop. So in our example we have the 5 bar pressure here, that is in the feet. So once it passes our valve, so this pressure of this stream, that should be 5 minus 1, which will be 4 bar. Similarly, after passing this valve, because up to this point we have a 4 bar pressure, after passing this valve we will have a 3 bar pressure for here and the same 3 bar pressure for here. So we will be considering a pressure drop of 1 bar for each valve, and the reason for this is, in the dynamic simulation we must have a pressure gradient that will move our system from feed to the outlet. The next is maintain the tank level at 50%. This is our set point. Valve specification data is given below. Once we go into these detail, I will explain you how and when we will use this data. So let's come over this one. It is saying that develop the data logger, which is strip chart for tank, liquid level percentage, and set point for the flow controller. So these are the 9 steps that we are performing in the dynamic simulation. The first one is the regular one, that you solve your steady state material and energy balances in HYSYS. The second is we size our vessel. The third one is we define our control configuration. And the fourth one is we perform our size control valves measurements and configure our control loops. Then we develop our strip charts and switch to the dynamic mode and run our simulation. Now in today's tutorial I'm going to work on these 8 steps one by one. However, we will not do this tune of the controller tuning, because that is an advanced level steps. So before I go into this lecture, I want you to make sure you have a good understanding about how you work on all these steps. So let's start with the step number one, which is to solve the steady state material and energy balances. So for that one, we need to develop this whole diagram into HYSYS. We have our feed has the water and air in that. So let's go to the HYSYS and we open a new simulation case. We go to our component list and we add water. You can just type in complete name and hit enter. It will be entered there. And then the second one is my air here. You can type in the name and click add. So we have two components, water and air, which we have added in our data bank. The next step is we need to choose our fluid package. So for this example, we can choose Peng Robinson. So you just click on your Peng Robinson and it is, as you can see that HYSYS is okay having this fluid package. There is no add button for selecting the fluid package. Some of the students asked me about this. How do you select that? Just click on this and it will be added in your system. As you can see that I have okay from both of them. So I have the component list, I have the fluid package, and these are the minimum requirements that I must have in order to enter into the simulation environment. Now I'm going into my simulation environment. So this is my object palette here. We need to go to the separator and we will look for the tank here. This is the tank that we need to bring into our simulation here. So let's open this and we can name the streams here. So I'm going to give it a name of stream number 1 to my inlet and 2 to my outlet, and let's say give it a name of 3. You can name them any name. You can provide them any name you would like to have. So now let's close it. In our diagram, the next step is we need to have some valves here. So in order to provide the valves, we go to our pressure changer, and this is the control valve. So we need to bring in our 3 control valve into the system. This is my first, this is my second, and this is my third control valve. Let's connect them to our main system. So for example, I give it a name of valve number 1, and my inlet is the feed here. My outlet for this valve is number 1. As you can see, this is what the system is looking like. Now you can close it. The second is we give it a name of valve number 2, and the inlet for this is my number 2 stream here, and this one will be my water. The third is we have the valve number 3. The inlet stream is number 3 and the outlet is the air. And now we can close this. Now in the next step we need to define our feed properties. So I click on this and let's see here. We have the feed, the water is 99.99 mole fraction and 0.01 mole fraction for the air, and temperature is 20 degrees Celsius and 5 bar pressure. So my temperature is 20 degrees Celsius and the pressure is my 5 bar. And my flow rate is 1000 kilogram per hour. The next is I need to provide the composition. So my water composition is 0.99 and this one is 0.01. These are all 1, and then you can press OK. So now my stream has been defined. Now the next step is, as I mentioned you, in the dynamic mode, we need to perform the calculations based on our pressure gradient. Now before I close this window, you need to go to the dynamics, and we are performing our calculations on pressure specification. Please make sure this is unchecked. By doing so, you are saying to the HYSYS that you are moving your system based on the pressure specifications rather than on the flow specifications. Now I close this. After that, we need to provide 1 bar pressure drop across each valve, and you double click on this stream. I have one valve already here. How do you provide the pressure drop for the dynamic system? You go to the dynamics and just enter here. So this one should be my 4 bar pressure. As you can see, HYSYS has simulated this. So I have the 4 bar pressure on this stream, and then I have the third valve coming in. So in the third valve, we have, go to the dynamics. So this one should be 3 bar. And this one is unchecked. As you can see that HYSYS has simulated this as well. The third is we go to the water stream. It's a dynamic, and this will also be third bar because air and water, they are coming in parallel. And my flow specification is unchecked. So now up to this point, as you can see that HYSYS has simulated my system. If I take you back to my steps here, we have solved steady state material balances. So up to this point, HYSYS has simulated my steady state system. The next is we need to add the specification for the valve. Now let's double click here, and you go to the dynamics. Now these are the specification for this valve. It is considering the pressure flow relation. The valve at this point is 50% open. Now this is my value of the CV. So I will go back to my table here now. Now CV is basically, which is the flow capacity of a valve in terms of the US gallon at the specified conditions. So in this case, if you look on this units here, it is US GPM, means gallons per minute, at 60 degree Fahrenheit and 1 psi. So our CV value for the feed is 75. So I provide 75 here. Because it is a standard, you will not be able to change the units here. As you can see, I don't have any units in the drop down menu. You just type in your 75 here. And make sure your pressure flow relation is checked here. Now we can close this and then go to the valve number 2. Again, we come here, and for our water outlet valve, we will see V is 53. So I make sure that pressure flow relation is checked, and this one is the 53. Now the next step is we need to provide our tank size. For this one, you double click on the tank, you go to your dynamics, and we have the volume of 5 meter cube for the tank. So here I enter my 5 meter cube. The time you enter your volume, it will automatically calculate the diameter and the height of your tank. This liquid percentage level is by default set up at 50. By that, it meant to say HYSYS is assuming that this tank is 50% full. I want to start my simulation from 0. So I just hit 0 here, and it will change my percentage level as 0, because will be no liquid in the tank. So this liquid percent level will be 0 as well. After that, you click on add configuration in order to link our dynamic system. I just want to show you. Now once you click on this, you will see that it has added a controller in my system. We can always rearrange this. Let's close this and come to our main solver. Now there is a button here that we can use. So if you go to flow sheet and just click on auto position all and click yes. For now I can remove this, and this is our system so far. So what is happening here? We have a controller developed for the level, and which is connected between the tank and the valve number 2. If there is an increase in the level of the water above the set point, this controller will open the valve so that water can go out and the level can be maintained. Now we need to configure this level controller here. The process variable on this system is your liquid percentage level, and how it is manipulating, as I mentioned you just, that it is manipulating my valve number 2 in order to achieve the desired level in the tank. So this all seems to be okay. And the next is you will go to your parameters, and here you can see that it is a direct controller, as I provide you some definitions for controller. This is my direct acting controller at the moment, or it could be a reverse acting controller. So at the moment this is my direct acting controller. That's what we want to have. Now a couple of the things you need to make sure, the mode is auto here. It could be even manual, but we want to keep it at the auto. And the set point, we want to have our tank 50% fill. So you just enter 50 and hit enter. It will set your level to 50%. Process variable is set at 0, and your output variable is 50%. Now then we need to provide the PV range. So range for the PV, let's go to our data here. So this is what we are doing now, level indicator controller. Our minimum PV is 0% and the maximum is 100%. So let's make sure this is here 0 and 100%, which is already there. Now we need to provide some tuning parameters. KC, which is the gain of the controller, and the gain of the controller for our level indicator is 0.5, which is the process gain parameter. And here we can enter 0.5. And our TI, which is the initial time for the calculations, is 5 minutes. So our TI is the 5 minutes. Okay, so we have defined all the operational parameters and the tuning parameters for our valve. Now before you close this, just click this faceplate and it will create a plate. This plate is basically, we can adjust our set point if we have to when we run our simulation. So I will keep this faceplate with me, and I can close this window here. Now the next step is we need to provide a controller in the feed and the valve number 1. So for that one, I need to go to my object palette. So you click on your flow sheet and click on the models and the streams, and you go to the dynamics and control, and this is my PID controller. Let's bring that into your simulation. Double click this. Now it is asking me what is your pressure variable. We know that we want to set up the feed as a process variable so that we can control the flow of the feed here. So you just click on select and go to your feed. Now in the feed we want to have the mass flow. You can search for the mass flow, or you can just type in mass flow here. So this is my mass flow here. Once you click this, the select button will be highlighted and you just select this. So I have entered my feed as a process variable. As you can see that HYSYS has connected my feed to FIC 100, which is my controller, PID controller. The next is we need to provide how we are going to manipulate this. For this one, you click on the select OP, and then we are looking to connect it with our valve number 1 in our diagram. So I click on the valve number 1, and it will be the actuator desired position. Click on this and then select. Now as you can see that now the controller is connected to my valve number 1. So what is happening here, if the feed is going above the set point, the flow rate is above the set point, then valve number 1 will be closed so that it can maintain the given set point. The next is we need to define the parameters of this controller. Now as you can see that it is on my reverse action, which is good, and then I need to provide the range for this. For that one, I go back to my flow indicator controller data. My minimum value is 0 and my maximum value is 3000. So my minimum value is 0 and my maximum value is 3000. As you can see that as I enter my 0 and 3000, it has automatically set up my set point on 1000 kilogram per hour. If you wish to change this, you need to change the flow rate of your feed, because this was 1000 kilogram per hour flow rate. That's what we provided when we were defining our feed here. But again, you can change it from the feed, and once you provide the minimum and maximum range, it will automatically set that as your set point. The next is we need to provide our tuning parameters. Again, I go back to my sheet here. So the process gain parameter for flow indicator is 0.5, and the initial time for the calculations, I'm providing it as a 1 minute. So this is my 0.5 and this is my 1 minute. I just want to double check this 0.5 and 1 minute. Okay. Right, so we are all good with this. Before you close your controller, let's have the faceplate so that if we have to change our set point, we can change this. So I will just keep it with me and I can close. So we are all done with the dynamic setup here with the controller configuration and everything. The next is we need to enter into our dynamic mode. Now before I go into the dynamic mode and show you how we work in that, so you can see that my system is on active mode and on hold. You need to make sure that your system is active and it is working as a steady state before you enter into the dynamic mode. Otherwise, dynamic mode will never work. And let's enter into the dynamic mode and let's click here on the dynamic mode. So as you can see that there are some issues with my setup. Once I click on yes, it will show me what are my issues. Now most of the time HYSYS has the ability that it can make these changes, as it is saying that disable the stream pressure specification. You can either do it yourself or you can let the HYSYS do it. If you want the HYSYS to do it, you can just click on the make changes and you can see that all changes were made. There is no remaining problems. So I can finish this and then I can go back to dynamic mode. Are you sure you want to switch to dynamics? I said yes. Yeah. So now our system is in the dynamic mode. I just want to show you something now. As you can see that system has put it on hold. Whenever you enter into the dynamic mode, the system is always on hold until and unless you run your simulation in dynamic mode. Now the next step is you go to the integrator, and these are the controls of your simulation basically. So I want to have the automatic simulation run. I want to have the units of the time provided in terms of the minutes. You can also change it based on your requirement. For now I will leave it at minutes. It is your current time and this is your acceleration. As you can see that on the acceleration, it is showing me speeds up or slow down integration by changing the integration time step. Acceleration of 1 is too fast for the simulation. I would prefer to keep it as 0.1. You can always change it in the simulation. And this is my end point here. You can provide any value or you can leave it non-stop. Just keep in mind, if you are keep leaving it as non-stop, you have to stop the simulation yourself, because HYSYS will not have any end time for the simulation. So these are all good here. I can just close it. And the next is we need to have a strip chart where we can see our simulation running. So you go to the strip chart and click on add, and click one more time on add, and here we need to add our navigators, variable navigator. The first is our tank here, which is V100, and we want to see how the liquid percent level change for this. You need to make sure it is entered into your simulation and then click on done. The second one we need to add is our set point here. For that one, it will be LIC 100, and we are looking for a set point here. And this one is done here. Before you close this, just make sure both of them are active and then click on the display. Now this is my data logger, which will run me the simulation here. And now I can run the simulation. There are two ways that you can run the simulation. The first is you can click on run. You can also run the simulation in going into the navigator and click on start. Now before I run the simulation, I just want you to recall that I'm not providing any end time, so simulation will keep running. So now I'm going to use this button to run my simulation, and what we can do, we can also move it up to this point. This level can also be adjusted, and now I'm going to run my simulation. Let me stop this and explain you this. So what is happening here, it is started from the 0 minute. My set point was 50% level in the tank, and once it start to fill up the tank, this is the time on the x-axis. This is the percentage of the level filled up. So at this point on this time, I have 30.58% of the tank filled up, and it is going to a set point of 50%. Now let me stop on this here again. Now at this point, as you can see that on this time I have the tank has achieved a 50% water level in it. Now at this point you can see that I have achieved a level of 50% in my tank. At this point my liquid level percentage, which is in the red color, it will start to oscillate around my set point. So I will again show you more. Yes, as you can see that it has achieved my level of 50%, and it will keep going because if the time is a non-stop, I have to stop it myself. Couple of things before I end this session. You can, if you make any changes, you can also reset your simulation and you can start over it again. I'm going to stop it at this point, and as you can see that this is my oscillation here. My liquid percentage level is oscillating around my set point. This is what is the characteristics of the PID controllers. Now let's say slow down the acceleration and see if we can have a better look on this or not. So let's reset my simulation, and I will start it from here. Now 0.01 is the better to visualize it. So this is my time at the 0, and this is my set point 50%. The tank is filling up with the water, and the tank percentage is increasing with the time. It is 18.49 and keep going. So as you can see that this is the time where it is going to touch my set point. However, because we are using the PID controller, it should oscillate around my set point. So this is the oscillation of leaker level percentage around the set point, which is the characteristics of a PID controller. I will stop this and I will show you the use of these phase bits. So I can change my set point. At this time it is 50%, and let's say I increase my set point to 60%. I want to have the 60% level filled up, and you can also change your flow set point, but I'm going to leave it here. And because I have changed my set points, I will reset my simulation, and let's start this again. Now you can see that my new set point, which is almost 65%, as I pointed up here, and the tank is starting to fill up. Again, it will go to my set point and it will oscillate around that. So as you can see that now it has achieved my set point. It will oscillate a little bit and then it will stabilize on my set point. The next lecture will be how we tune these parameters of our controllers. But just make sure you look at this tutorial and you are familiar with how we set up a dynamic simulation. Now we have achieved our set point, so I will stop it here. If you have any questions, please feel free to email me or you can see me in my office. Thank you.